Okay, good evening, everybody. Again, sorry I wasn't at class again today. My son is still sick. Hopefully he'll be back there tomorrow. If you didn't hear, I'm postponing the quiz for Chapter 8 until I feel like we've had enough time to make sure you're ready. So I don't know when it's going to be. Maybe Thursday, maybe Friday. I don't know. We'll figure it out once I get back. Anyway, so as you notice, I'm still using the green screen today. I'm going to try it a couple more times. I had some feedback on it that some people liked it, whatever, but there's some issues with the color green when I was writing it. So I'm going to use this color for green today. It looks kind of yellowish. I'm going to call that green and see if that's not better. It's like if you really looked at it, it's like an army green. So we're going to call that my green color and see if this doesn't work a little better. Okay, so again, today we're going to be doing multiplying polynomials. This is something we've already done. We did this very first quarter. And so a lot of it will review, but I'm going to show you a couple of other things that you may have seen from other people, especially older siblings or parents. Okay, so when we do these, I'm strongly encouraging you to use generic rectangles. That's what we used at the very beginning. I believe it's the best way to do it. It's based on some pretty solid math practices, and it's easy to do. And you won't forget anything. It's kind of foolproof. So let's take a look at it. The first thing you're going to do is you're going to draw yourself a rectangle, and then put one of these on the wall and one on the roof. Now, if I have one with a negative sign, I always put that one on the roof, because then I don't have to worry about that negative sign looks like where I put it. So I'm going to put it on the roof here, although you also can put it on the wall. In fact, I think today I'm going to put it on the wall just to show you how you would need to write it if you do that. So for this one then, I'm going to put this one on the wall, so that's 4x. And then what I don't want you to do is this. Whoops, I don't want you to do that because it looks weird. I don't want you to do this for your minus sign, because that looks like a fraction line. We don't want it to look like a fraction line. Instead, we want it to look like a negative. So if you do that, make sure you put the negative with the 2, like that. So 4x minus 2, and then going across the top, I have x plus 3. Now, as we recall from before, anywhere I have an addition or subtraction sign, I draw a line. So what I've created here is a 2-story, 4-bedroom box. Now, this first box is the one that most people have been messing up. X times x. We're multiplying the same bases. When I multiply the same bases, what do I do with my exponents? I add them. So x times x does not equal x. X times x equals x squared. So this first box then is 4x squared. It cannot be 4x. That doesn't make any sense. Okay, and then this box here is going to be 4x times 3, which gives me 12x. And then this box here is going to give me negative 2 times x, which would give me negative 2x. And then this box here gives me negative 2 times 3. Notice that I'm just lining up the sides of the walls there. And actually, in fact, what I'm finding is the area of each one of these boxes. So there we go. So now my last step is to combine like terms. And I'm always looking diagonal. Those are my like terms. So I end up with 4x squared, and then negative 2x plus 12x gives me positive 10x, and then minus 6. So this is my final answer. All right, I'm going to show you another way of doing these problems on the next slide, which I don't like it as much as generic rectangles, but it certainly is adequate. Okay, for this method we're going to use what's called the vertical method, and the reason I like this method is because it kind of reminds you of the way you used to multiply 3-digit times 2-digit numbers. It's based on the same idea. I don't like it because it's very limited in what it can do. As you recall, my kind of theme for this class is I like to teach you one thing that you can use over and over again no matter how hard it gets, and preferably do multiple problems with it. That's the beauty of generic rectangles. I think you're going to see next chapter that generic rectangles are ridiculously helpful in solving lots of different types of problems, where this vertical method here, it pretty much is only going to do multiplication. It doesn't do anything else what we call factoring. It's hard, you can't factor going the opposite direction of vertical method. So if you can hear, that's my dogs in the background. I'm sorry about that. So vertical method, though, it does work pretty well. So what you're going to do is you're going to take one of these. Doesn't matter which one, 4x minus 7, and then you're going to multiply that by the other one, and you stack them vertically. 2x plus 1. Just like we used to do when we were multiplying like 47 times 21. And now, you literally just multiply like normal. So 1 times negative 7 gives me negative 7. 1 times 4x gives me 4x. So I get 4x minus 7. Then the second one is going to be 2x times negative 7 gives me... Now here what you have to remember is in the previous, when you were learning how to multiply, we had to put a 0 in there as a space holder. So my next one is going to go here, and that's going to be negative 14x. What I don't love about this is a lot of students forget that negative right there. They say negative, or they say 2x times 7 instead of 2x times negative 7, where in the previous slide it looked a little bit more like negative 7. And then, of course, we have 2x times 4x, which gives me, and you got to remember again, in this case, those are both 1s, so that's going to be 8x squared. And then, like we did before, we would add those two together. So negative 7 plus 0 is negative 7. 4x minus 14x gives me negative 10x, and 8x squared. 8x squared. So that's my final answer. Now, I'm okay with this method. I don't love this method, but I'm okay with it. It does do a nice job of lining everything up for you. It's familiar to you. You've done something like this before when you were doing multiplication problems that look like this. 37 times 25. It's based on the same thing there, and it gives you the correct answer. What I don't love about it is it's very limited. All you can do is multiply polynomials together. You can't start with this and go back to there like you can with generic rectangles. So it's okay. It's not my preference. Generic rectangles definitely is my preference, but it's better than the next one I'm going to show you. The next one I'm going to show you I'm actually not a fan of at all, and I'd prefer you guys not to use it. I'm going to show it to you because every math teacher in the world uses it or knows about it, and so I don't want you to not know what's coming, but it is by far the least beneficial way to do them. Okay, so here we go. This is called the horizontal method, and many of your parents or even perhaps yourself may have heard of this before. It goes by another name, but the other name is very limited in that it only does a problem like the one I'm doing right here. I don't like this other name very much. I prefer not to use four-letter words that start with the letter F. Especially in a school setting, to me, that's something we want to be careful of, and some people might be offended if we're using the four-letter F word. But a lot of teachers use it, a lot of students know it, a lot of parents know it, a lot of older siblings know it. So because everybody around me knows it and is using it, I'm going to go ahead and use it as well. Although I am, basically very opposed to using the four-letter F word in my lessons, but I will do it. So, of course, I'm sure we know the four-letter F word is FOIL, F-O-I-L, and I just don't think that's appropriate for a school setting. I would rather us not use that word because it is very limited on how much it can help you. There's only one type of problem it can do, and that is a binomial times a binomial. That's it. The only thing this does is a binomial times a binomial. The previous slide can do a binomial times a trinomial or a monomial times a trinomial. And of course, generic rectangles can do any size polynomials. But FOIL only does a binomial times a binomial. As you know with me, I do not like teaching you things that are very, very specific to one type problem. I want to teach you something you can use on lots of different problems. But I'm going to show you it one time only, and then I promise you, I will never use the four-letter F word in my class again because I don't want to, offend anybody or damage anybody's intellect. But here's how it works. So what you do is you take your problem, 2x minus 1 times 3x plus 6. And you take your first term. That's what this stands for. That's F stands for the word first. So here's my first term, and here's my first term. And I multiply these two together. So 2x times 3x. We have the same issue that when you're multiplying the same base, you got to make sure you're adding your exponents. So 2x times 3x equals 6x squared. That's the F. The next one is O, and O stands for outside. So I take the outside term here and the outside term here. So those two are multiplied together. So 2x times 6 gives me 12x. The next one is inside. So that is this inside one here and that inside one there. One reason I don't like this again is you got to be very careful. I'm not multiplying 1 times 3x. I'm multiplying negative 1 times 3x. So it becomes negative 3x like that. And then the last one that we do is this stands for last. And so I take the last term here and the last term there, and I multiply those two together. Again, that's negative 1 times 6, which gives me negative 6. At this point, what I need to do next is I need to combine like terms, and you'll see that I have like terms right here in the middle. So 12x minus 3x gives me 9x, and I just drop everything else down. So 6x squared plus, and the reason it's plus is because it's positive, and then minus 6. So this is my final answer. Again, it works. You can only use it for a binomial times a binomial. You can't do a binomial times a trinomial or a monomial times a trinomial. It doesn't work. So this is my least favorite. Of the 3 methods I just showed you, this is the one I hope we use the least. And I'm never going to show you again. If you don't understand it, then learn a different way, because the other ways are both better than this one. All right, lastly, I'm going to show you an example. This would not work for the 4-letter F word method. It doesn't work for the 4-letter F word method because if you go, okay, first this one and this one, then you go outside this one and this one, and then you go inside this one and this one, and then you go last, which would be this one and this one, you may notice that, weird. What happened to this one? How come nothing happened to this one? That's the problem with the 4-letter F word method, is because that method doesn't work once you get bigger than a binomial over here. I have a trinomial, it doesn't work. So I have to learn a whole different way of doing it. In fact, one of the ways they teach you is the vertical method, so why not just learn that at the beginning? Or do generic rectangles. That always works, no matter how big they are. So again, I'm going to do this with generic rectangles. And you'll see that it's no more difficult with a generic rectangle than it is without a generic rectangle. I'm going to go ahead and write it with the first one on the wall, which is 2x, and then notice where I put my negative 1, and that gives me 2 stories. And on top, I have 3x squared plus 6x minus 3. Everywhere I have a positive or a plus or a minus, I draw a line like that. And now I'm going to multiply. And remember, we multiply in exponents, or multiply in the same bases, we add the exponents. So that's 6x to the third. And then 2x times 6x gives me 12, put a 1 there, x squared. And 2x minus 3 gives me negative 6x. And then I'm going to do the bottom one, which is negative 1 times 3x squared, which is negative 3x squared. And negative 1 times 6x gives me negative 6x. And negative 1 times negative 3 gives me positive 3. Finally, I'm looking for like terms. My like terms will be diagonal like this. So I have 6x cubed. And then negative 3x squared plus 12x squared gives me 9x squared. And then that right there, negative 6 minus plus negative 6x gives me negative 12x, and then plus 3. The beauty of generic rectangles is no matter how big the terms get, we keep doing it the exact same way. The boxes just keep getting bigger, but I change the process not at all. And then the beauty of it that you'll see in Chapter 10 is we actually can reverse the process. And what I mean by that is we can go from something that looks like this and go back to something that looks like the original problem. It's called factoring. So we can reverse it, where the other two methods you cannot reverse it to go back. You have to learn a whole different way of factoring. Okay, so that's it. That's the notes for today. We'll be doing a lot of this multiplying polynomials, and again, my preference is generic rectangles. I can accept vertical, but I will frown upon anyone who chooses to do the horizontal method. You're just making life harder on yourself. Okay, I really hope to be at school tomorrow, and hopefully I will, and I'll see y'all tomorrow.